Welcome. This is the very first video on the topic of nomenclature, and as with the previous videos, we're going to start with alkane and work our way into alkene and alkyne. The reason being, if you know how to do it for alkane, it's just there's only a few minor changes that you have to make when it comes to alkenes and alkynes. Now, I have given these three tables, okay? How much you have to memorize, I'll leave that up to you. I don't think you have to really memorize anything after a couple of times you practice, but there's three tables. Let's start with the first table on the very top, and the title is number of carbons in the longest and continuous chain alkane, right? Now this is commonly left out. They just say number of carbons and then they start listing these, but there's a reason why I have this, okay? Now, if you already watched my line structures, I have specified the importance of longest, okay? And longest and continuous, I'm going to demonstrate that, okay? Because when you draw structures, okay, you have to determine the parent chain, which is also going to be your longest and continuous chain, okay? Now, we've already drawn isomers. Sometimes we'll have 7 and then we chop off 1, make it 6, and then chop off 1, make it 5, and so on, right? So every time you're given a structure, the first thing you have to figure out is what is my longest and continuous chain of carbons, okay? Sometimes it's commonly written as straight chain. That is tricky because, well, sometimes your chain could be purposefully bent, and so you always have to look for longest and continuous sequence of carbons, okay? Now, if your longest chain is only 1 carbon, well, that's methane. If your longest and continuous chain has 2 carbons, then it's ethane, 3 is propane, okay? All nomenclatures, in my view, has 2 things, your first name and last name, okay? Last name comes from the longest and the continuous chain. So however many carbons you have in the longest and continuous chain in that particular structure, then the last name is, if it's an alkane, it all ends with A and E. If it's an alkane, it ends with E and E, which you will see. And if it's an alkyne, it ends with Y and E, right? Let's move on to the second table. Now, all of this only makes sense in the context of an example, and I will do a couple of examples right away when I finish up with the screen. So number of carbons in the branch or substituent. I also mentioned the word substituent or substituents in my drawing line structures. So you are familiar with it. So once you've identified your continuous long chain, then you look for what is off that long chain, which is called branch or substituent. Now, if your branch or substituent contains only 1 carbon, that's methyl, 2 is ethyl, 3 is propyl, 4 is butyl. Now, if you see that this table and the table below are the same, irrespective of whether the branch or substituent is coming off an alkane, alkene, or alkyne, because a substituent is a substituent. Okay, these will never change. But if you see, one way to remember it is if it's methane, it's methyl. So basically replace A and E by a YL. As I said, this will remain the same irrespective of what the long chain is. A number of identical substituents. Again, this word identical is important. Sometimes you may have 2 methyl groups that are either on the same carbon or on a different carbon. Okay, if you have 2, that's di, 3 is tri. You only use it for identical. Don't use, if you have 2 substituents that are different, then you don't use di. If you have the same substituent on 1 single carbon or 2 different carbons, then you use di, tri, tetra, and penta. Okay, so let's see this in action. Here's a compound, and we know this is an alkane because it fits the CnH2n formula. So what I'm going to do here is actually write just regular structure and probably one with a line as well. So, right? So Ca5, 6, and 7. Now, in this case, all carbons are in a straight continuous sequence, and that long chain contains 7. So if you go to the table and you see there's only 7, and all 7 are in one long continuous chain, then this would be heptane, right? because 7 is heptane. Now let's try a different isomer. Let's draw this time. Okay, I'm going to write this one. Okay, moved one below. So that would be 4, 5, 6, 7, right? Now, if you watched my drawing line structures video, I said, which side do we start numbering from? Well, this is the carbon right here. I've shown with an arrow, contains the substituent, which is this, right? On either side you look, this side has only 2 carbons. This side has 3 carbons. So you start numbering from the side that has least number of carbons. So it'll be 1, 2, 3, 4, 5, and 6, right? So it's in the third position. And as I said, if your substituent is containing only 1 carbon, that's methyl. So the way you do it is, as I said, there's a first name and the last name. So you write 3, which is the physical location where the substituent is. There's only one substituent, so there's no need to use mono. 3 hyphen methyl. And how many carbons are in the longest chain possible? There's 6. So that is 3 methyl. 6 long chain continuous carbon is hexane. So 3 methyl hexane. That's how you write the naming. Now let's do one more. So let's do CH3, CH, CH. How about let's do this? CH2, CH, CH3. I believe I've already got 4, 6, and 7, right? Now you look for the longest chain first, and the longest chain in this case seems to be the 5 carbon chain. Which side do I start numbering? Well, I got a substituent here, and I have a substituent here, right? Right? On this side I have 1 if I pick this, and then I have 4, right? But if I pick this one, then I have 1, and then I have 4. So it's the same. So it really doesn't matter which side I start from. So for convenience, I'm going to start this. So this is an exceptional case, which is why I showed it demonstrated, because in this case, it doesn't matter which side you start numbering, because it's right on either side. It's going to be the same. So now how do we do it? Well, we have 2 substituents of the long chain, and then they're both the same. One is in the 2nd spot and the other is in the 4th spot. So you say 2, 4 dimethyl, di as in 2, and then the long chain contains 5 carbons, so it's pentane. So 2,4 dimethyl pentane. There's something I have not done here, but I leave it up to your imagination. Say one of your substituent is ethyl. Say you have this hanging off a chain, okay? And then you have a methyl. Which one? Say this is in the 3rd spot, say this is in the 5th spot, and then the long chain, say, happens to be octane, okay? So how do we put it together? Okay, I don't want to create a specific example in lieu of time, but this is a methyl substituent, right? This is an ethyl substituent because it's contained 2 carbons. This is contained, in terms of alphabet, E comes before M. So you say 5-ethyl. Keep in mind, this is not a real example. I just made this up purely connecting this, okay, like this. 5-ethyl hyphen 3-methyl and then octane. This was purely made up, okay? This is not part of this C7H16. Instead, I'm just trying to drive the point across right away, because this is a special case as well. When you have more than one substituent, you go by alphabetically arranging whichever one comes first, not by where they are located, but by the alphabet. All right, so that's all I want to say for alkane nomenclature. I'm going to make one more video where instead of it in this full structured format, I'm going to use a line structure and drive the name. So I only want to make 2 videos, and I'll give two practice problems at the end of the 2nd video. All right, so stay tuned.